And this is the Mechanics Homework Booklet question 46. So we've got a steel wire of that length and that diameter being attached to a rigid beam. 25 gram mass is attached to the free end of the steel wire and placed against the underside of the beam as shown. Although actually the diagram is showing a gap, which never mind. The 25 gram mass is released and falls freely until the wire becomes taut. The kinetic energy of the falling mass is converted to elastic potential energy in the wire as the wire extends to a maximum of 1 millimeter. Energy conversion to other forms is negligible. So for maximum extension of the wire, completes parts A and B. So we've got to show that the elastic potential energy stored by the extended wire is 0.29 joules. The point is here, we don't know anything about F, we don't know anything about X, so we're not doing half Fx, half Kx squared. What we do know is it's equal to the kinetic energy, and the kinetic energy in turn will be equal to the potential energy that's lost. So the elastic potential energy will be equal to the initial potential energy, that gets you your first mark. That will be equal to m, 25 times 10 to the minus 3, g 9.81, h 1.2. You could argue that it should be 1.201 because it's going to fall the 1.2 meters plus the 1 millimeter extension, but that just wouldn't make sense in terms of the significant figures of the 1.2 meters of that original length. Work that out and you get 0.29 joules. Because it's a show, I would have been quite tempted to show that figure somewhere in my working. We're then asked to find the tension in the wire, and this is where we are going to use the elastic potential energy being a half Fx. Rearrange that, gives me F equals twice the potential energy upon X. Lob the numbers in and I get 289, so to two significant figures, 290 newtons. Again, we're not required to give the correct number of significant figures, so no harm in too many. We're then asked to calculate the stress in the wire. We've got the information about the wire which allows me to calculate the area. That gets me the first mark, and doing the stress as a force divided by the area gets me the second. Back in B, the first mark was for essentially that sum, and the second mark for the answer. Then finally calculate the strain in the wire. We've got, not finally, actually calculate the strain in the wire, we've got the extension divided by the original length, is that value, 1 mark in total. Finally, hence, calculate the Young modulus for the steel of the wire, and we've got the E is for stress divided by the strain, was equal to the stress that we've worked out divided by the strain we've worked out, gives me that value, 2.2 times 10 to the 11. I've not written on units there, that's no good. I should have pascals in there. And again, 1 for the sum, 1 for the answer with units. Not required here, but it is worth pointing out that we've made a big assumption there that we are only on that straight line part of the graph. We're assuming that the elastic limit has not been exceeded. Otherwise, that value of stress upon strain isn't valid. Remember, the Young modulus is stress divided by strain on the straight line elastic section of the stress strain curve. So that's the Mechanics Homework Booklet question 46.